This video is for Mrs. Cucci's College Now PreCalculus class. We are on lesson 5.6, graphs of transformed sine functions and cosine functions. You will need to have graph paper out, a ruler, and a pencil preferably, so make sure that you have that out in front of you, as well as having the document open and available. Okay, so by the end of this lesson, you will be able to graph transformations of y equals sine x and y equals cosine x in the form y equals a cosine bx minus c plus d, and y equals a sine x sine bx minus c plus d, and determine the amplitude, period, and phase shift of each of these functions. We're going to be able to graph sums of functions, graph functions or damped oscillations, found by multiplying trigonometric functions by other functions. Okay, so those are our goals for this lesson. This lesson will span at least 2 days. All right, so graph of f of x equals sine of x plus d, with d equal to 0, is shown on the next page. What we're going to do is we're going to grab that slider and we're going to move it around, and we're going to record in our notebook how the graph changes. All right, so what we have right now is we have y equals sine of x. Okay, notice that d has not changed. D is currently 0. Oops. All right, so what we're going to do is we're going to take this slider and we're going to grab it and we're going to move it. And what do you notice that happens as we move this slider? D is 2. What's happening? 2.5, 3. What's happening to my sine function? Okay, and if I go in the opposite direction, when d becomes negative 1, negative 2, negative 3. Okay, how is this function changing? So I want you to take a minute. I want you to play with it a little bit more and come up with a conjecture as to what d does to my function. Okay, so hopefully you have determined that d vertically translates our trig function. Vertically meaning up and down. Okay, so d actually takes the entire function and translates it vertically for us. All right. Now, another way we could say what d does is it changes our midline. Okay, or d is our midline is another way to say it. So if I were to take this and move it up to 1, the middle of my graph is at y equals 1. It's halfway in between the maximum and the minimum. Okay? The line halfway between our maximum and minimum is what we refer to the midline. The midline is d. All right? So when we go and look at what each of these variables means, d stands for midline. Okay? All right, so what you're going to do now is we're going to sketch a graph of y equals sine x plus 3. Now, notice the only thing that's different here is we have that plus 3 on the end. Okay, so go ahead and take a piece of graph paper and we'll get started. Okay, so we have y equals sine x plus 3. So notice we have that plus 3 on the end. So I know my trig function is going to be shifted up 3. So what I like to do is I like to kind of put in a dashed line at my midline, which we know to be 3, okay? Because this essentially becomes like our new x-axis, what we're going to graph everything around. All right, so I know sine at 0 is 0. Sine at pi over 2 is 1. Now, we're going from this y equals 3, so we're going from that, so it's 1 up from there. At pi, it's 0, so in our case, 3. 3 over 2, negative 1, or in our case, 2. And then back up to 0. Okay? So it's like that y equals 3, that line y equals 3 is like your new x-axis. Follow that trend going backwards. And you have your cosine curve, or your sine curve, sorry about that. This is the worst looking sine curve ever, I apologize. You have your sine curve that has simply been vertically translated up 3 units. Okay? So again, you're going to put in a dashed line at your midline, and you're going to basically graph your function around that midline. Okay. All right, so the graph of f of x equals a sine x with a equals 1 is shown on the next page. We're going to drag that slider, and we're going to come up with a conjecture about how a is affecting this graph. All right, so right now, a is at 1. So as I move this slider, and I change 1 to 1.5 and to 2, notice what's happening to my function as a increases in size. Okay. So I'm going to go back down to 1. As a gets smaller, what's happening? So I want you to take note from 1 to negative 1. How is this different? 1 to negative 1. Okay. So what is that value of a doing to my function? So take a minute to think about that. And write your conjecture in your notebook. Okay, so hopefully you've decided that what happens here is my function is being stretched vertically. Okay, actually what's being affected is what we talked about last video, is the amplitude of the function. Okay, the difference between, or the distance between the midline and the maximum, or halfway between the minimum and the maximum. Okay, so what's being affected is your amplitude. Now, when I went to negative, essentially what that has done is it's created a reflection over the x-axis. So if your amplitude is negative, you're reflected over that x-axis. All right, so amplitude of the graphs, y equals a sine bx minus c plus d, is the absolute value of a. So if I ask you for amplitude, you're always going to give me my amplitude as a positive value, never as a negative. That negative sits there for graphing purposes only, okay? All right, so we're going to sketch the graph of y equals 2 cosine x. So again, we're always going to start with our midline. Notice we don't have anything added on the end here. So our midline is going to stay as that x-axis. The only thing that's being changed here is my amplitude, so how I'm stretching this cosine curve. So go ahead. Put some axes on your graph paper and we'll get started. Okay, so our amplitude for this function, we're doing y equals 2 cosine x, our amplitude is 2. Okay, that means we're going to rise 2 units above and below the midline. Since the midline, there's nothing being added or subtracted, it's simply going to be this x-axis. Okay, so cosine generally starts at 1. But because we have an amplitude of 2, we're going to stretch that to 2. At pi over 2, cosine is 0. At pi, cosine of pi, and here's how you can do it algebraically. Cosine of pi, we know cosine of pi is 1. 2 times 1, or is negative 1. 2 times negative 1 is negative 2. So that's how you get those values. And if you want to do that math out, you're more than welcome to. 3 pi over 2, we're at 0, and 2 pi, we're going to be back up to 2. Okay. We're going to follow that trend in the opposite direction. Negative pi over 2 is 0. Negative pi is negative 2. Negative 3 pi over 2 is 0. And negative 2 pi is 2. Sketching our curve. And here's your cosine curve with an amplitude of 2. So again, it's simply been vertically stretched, like silly putty when you stretch it out. You're stretching it so that it has an amplitude of 2. Rise or fall above or below the midline. Okay, so the next one we're going to look at is y equals negative 1/2 sine x. Okay, so our amplitude is 1/2. And remember that negative right here states that we're going to have a reflection over the x-axis. Okay, so if we generally would have a point at 0, 1, that point would now be 0, negative 1. All right, so it's just that simple reflection. The amplitude is 1/2, which means I'm only going to go up and down 1/2 a unit from that midline. Midline is 0 because nothing's added or subtracted on the end. All right, so sine at 0 we know is 0. 1/2 times a 0 is still 0, so that doesn't change. pi over 2, sine is usually 1. But because I know that this whole piece is equal to 1, 1 times negative 1/2 is negative 1/2. So it's actually going to go down a half a unit. We're back at 0. 3 pi over 2. 3 pi over 2 is generally negative 1. But since we know we're being reflected, it's going to become a positive 1. And then back down to 0. Follow that trend on the way back. 0, 1, 0, negative 1, 0, 1, 0, negative 1, 0. And sketch in your sine curve. Okay, since this value here was less than 1, this was vertically shrunk. Okay, we actually compressed this. And you want to make sure you label your curve. Okay. The graph of f of x equals sine of bx with b equal to 1 is shown on the next page. You're going to drag those sliders and write your conjecture in your notebook on how b affects the graph. Okay, so right now it's at 1. I'm going to go ahead and move that. Oops. So as I move that value, how is my function changing? Okay. So I'm going to go back to 1. I want you to notice that we have one full curve between 0 and 2 pi. I want you to keep that in mind here, okay? One full curve between 0 and 2 pi. I want you to watch the interval from 0 to 2 pi. I'm going to go ahead and move this. Now, look what's happened between 0 and 2 pi. I have 2 full curves between 0 and 2 pi. So what does that value of b do to my function? So I'm going to pause here. I want you guys to write down that conjecture. Okay, so hopefully your conjecture stated that b represents what we call the frequency. Frequency states how many full curves on the interval from 0 to 2 pi. Okay, so how many full curves, so if it starts at 0, it ends at 0. How many full curves do you get between 0 and 2 pi? And since b is 2 in this case, I got 2 full curves between 0 and 2 pi. Okay, so from frequency, we find something called period. Period is how long it takes to get one complete curve. Not how many, but how long, okay? The period of a graph, you can get from the formula 2 pi divided by b, where b is the frequency, or how many full curves happen between 0 and 2 pi. Okay, so 2 pi divided by b, that's how we find how long it takes to get one full curve. Okay, so we're going to sketch the graph y equals sine 4x. Okay, so again, what that 4 tells me, a frequency of 4 tells me, is I'm going to have 4 full sine curves between 0 and 2 pi. Okay, so what I need to do is I need to figure out how long it's going to take me to just get one. That way I can kind of break this up. So in order to figure out how long it's going to take me to get one, I need to find the period. And again, period is 2 pi over b, which is going to be 2 pi over 4. That reduces to pi over 2. So what that tells me is between 0 and pi over 2, I'm going to get one full sine curve. So what I'm going to do, I'm just going to put halfway points in between all of these, just to give myself a little bit more of a guideline on how I can build this. Okay? So again, I need one full curve between 0 and pi over 2. We know sine starts at 0. So I want to get one full curve here. So I know halfway in between, if it starts at 0, it's going to end at 0, and halfway in between I'm going to have another 0. I know that. Okay? In between my two zeros, I'm going to go to my maximum and then my minimum. So here's one full sine curve. I have to do this 3 more times to get to 2 pi. So again, I'm going to have zeros all the way through this. I'm going to go to my maximum and then my minimum. My maximum, my minimum. My maximum, my minimum. Okay, and then I'm going to follow that same trend on my way back to negative 2 pi. Minimum, maximum, minimum, maximum, minimum, maximum, minimum, maximum, 0. And I know it's a very ugly curve. I apologize. Okay, so essentially what I have done here is I have one full curve here. Here's my second one. Here's my third one. And here's my fourth one. Okay, so I have 4 full cosine curves. Here's your 4 full cosine curves between 0 and 2 pi. That's how you state frequency. Okay. All right. Okay, so the graph of f of x equals x plus c with c equal to 0 is shown on the next page. We're going to drag that slider and record in our notebook how the graph changes. Don't jump to conclusions about it yet. Okay, so I'm going to go ahead and take that value and I'm going to simply move it. Maybe. Possibly. There we go. So as I'm moving this, what's happening to my graph? Okay, so I'm going to go back to 0. I'm going to move it to 0.78. Which way did it go? Okay, look at it. Which way is it going? I'm moving in a negative direction. Which way is it going? Okay, which way is it going? All right, so now build your conjecture, write it in your notebook. What do you think is happening here? Okay, so hopefully your conjecture stated that this is a horizontal translation. Another word for horizontal translation when we're talking in terms of trig functions, we call this a phase shift. Okay, this is what we refer to as a phase shift. So it horizontally translates it left and right. Now, this constant, again, the word is phase shift. You're going to see it added or subtracted inside those parentheses to the variable. Okay. When we're looking for the phase shift, if we're trying to determine what the phase shift is algebraically, you do have to divide out the frequency in order to determine what the phase shift is. The C over B, that's your phase shift. Okay. So if your frequency is something other than 1, you have to divide everything there by the frequency, pull it out, then this term here is your phase shift. Okay. So it's a little tricky, and we'll do some practice with that. All right, so we're going to sketch a graph of y equals sine x minus pi over 2. So essentially, what this is doing, since this is minus, that tells me that this is going to move to the right pi over 2. And we know pi over 2 is 90. Okay, so what we said is this is going to be a shift to the right pi over 2 units. So everything's going to be moving in this direction. Okay, this direction. So what I'm going to do is I'm going to kind of put in a fake y-axis. I'm just going to put in a dotted line at pi over 2 just to give myself kind of a vantage point of where I need to be graphing this function. Nothing else is different except for that phase shift. Sine still starts at 0. It's going to go to its maximum, 0, minimum, 0. Except instead of starting at the origin, I'm starting at pi over 2. Okay? So sine now at pi over 2, it used to be here, now we're over here, is still going to be 0. Then at pi, we're going to be at 1. Pi over 2, we're going to be at 0. And then 2 pi, we're going to be down to negative 1. Okay? So it still follows that same exact trend, except we've shifted it over. So now we're going to follow that trend. It's going to go up to 1, down, and then at 0, we're going to be at negative 1. And then follow the trend, 0, 1, 0, negative 1. Okay. So we're just going to sketch that in. So again, it's the sine curve. It's simply been shifted so that we're starting at pi over 2. Okay, so that's where we're going to stop today, guys. Please come prepared with any questions, and I will see you tomorrow.